Now, I quote here David Allen Coe. It is not only the beauty of the building you should look at, it is the construction of the foundation that will stand the test of the time. I think this ideology is better imbibed by BN Precast. BN Precast Private Limited has been conceived to usher in a new way of industrialized construction that provides precast elements with extreme durability, affordability, adaptability, livability, and environmentally sustainable buildings that have high consistent quality and ensure high efficiency and fast construction. Let me invite Mr. Nishant, Mr. Samir, and Mr. Pau to talk about their industrial project right here in Ahmedabad. Thank you.
So good afternoon. I think it falls upon me to wake you all up after your lunchtime nap. So today I'm going to talk about a project which we are doing for an industrial building. It is a pharma factory, and it combines both precast as well as a lot of PEB components, steel components. But before that, I'll just give you a brief idea of what BN Precast is and what we do. So we started making precast building structures 3 years back. The first project was Udgam School at Jodhpur Char Rasta, Ahmedabad. It was a G+3 structure. It was a column beam structure, and since then we have done a lot of structures: wall frame, column beam, commercial, institutional, as well as industrial projects. You can visit us at our stall to find out more about that. So today I have with me my design team, Mr. Samir Bhai and Parva. I think they'll fill in for me afterwards if you have any queries later on. And we can start with the structure we are talking about today. So this is a factory building at Sanand. It is located at Sanand, so it is about 60 kilometers from our factory, which is at Jalundra Mota village on Naroda Degam Road. Logistically, it is a simpler project because there is highway connectivity throughout. Trailer connectivity is available everywhere. And the site of the project is also on the main highway. So this is a building of how it will, the key features of this building were, it is a 115 meters by 77 meter building with 2 floors, the ground floor and the first floor. That is a mezzanine floor. Eave height is 12 meters on the sides, the ridge height is around 16.5 meters. We have taken a RCC precast structure and used PEB for the rafters as well as some of the mezzanine sections. HVAC and machine floor is at 7.5 meter level, which is done using steel PEB. The 4 mezzanines on the 4 corners of the building, I'll show you more details of that. Those are at a height of 5.95 meters, and those are RCC structures. They're using double T's and beams columns. We also have a U-shaped beam, or the top tie beam is U-shaped for the water downtake. So we have combined the beam with a drain as well. And it also includes a ridge for the facade section, which is visible on the top, where the facade of the building will be. Yeah, this is better. Okay, so this is much better. So the facade of the building above the ridge, above the eave height, is 4.5 meters, and this allows the building to be, बाहर से देखेंगे तो it looks similar. So this was the original proposed plan from the client, where we had 22 number of rafters, we had 12 numbers of mezzanine beams, there were 16 gable end columns, and there were only a few lesser number of columns in the central part of the grid. We did a lot of hera-feri. We changed the location of the columns, which increased the sizes of the spans and everything, and got it down to 18 numbers of rafters, 9 numbers of mezzanine beams, and 12 number of gable end columns. This reduced the structural system on the top as well, and we rationalized the loading. We did value engineering on this building for 1 month, and got the tonnage of steel for the PEB to reduce to by 900 tons. So that is why, by combining what we do best, which is RCC columns take up lot lesser, I mean, they are much more efficient at carrying loads than your steel columns at a much fraction of the cost. So we utilize that for that. For the rafter, we have a 77-meter span originally, which we have now rationalized by having 2 connections in the center. All the central columns are columns with a capital on top, and this capital includes the anchor bolts for the PEB. Yeah. So this grid basically shows the PEB structure which comes on top of the RCC frame. And currently this project is completed with the roof, and we are completing the final finishes. And another building is also ongoing in the back, which I'll show you. Like all the previous speakers, we are in India. We comply with all the IS codes and have got it proof checked here in Ahmedabad itself. And the client also has an external proof checker who has proof checked our structural designs and validated the design. So as an EPC contractor, like others also mentioned, the importance of having a design responsibility as well as a manufacturing responsibility and also execution responsibility rests on a single contractor. This is good from the perspective of the client because he gets a single responsibility window. There is no escaping ke ye iska fault tha, ye iska fault tha. There is only one person who is responsible for everything. The total liability of the building is with BN Precast. I'll share the PPT so I think they can get all the details anyways. This is some of the loading. Mezzanine floor has a load of 800 kg per square meter, and on the turquoise area, there's a 5,000 kg per square meter load. All the 4 corners are RCC, and the building was originally designed as supposed to have a common column where they can have an extension later on. So currently we're constructed as the right portion, but it can take the other building also. So future expansion is catered for. A lot of connection details are there. I think I'll share the presentation, and we also have a presentation on joints, so they can take care of that in more detail. So I'll skip to that part. Yeah. So what I'll do at this stage is we can show you a short collage of images of the site, and that will give you a general idea of how we started and where we ended in the whole project. So overall, I'll just continue, and then whenever they play the video, we'll continue with that. But the idea is that when you decide on doing something, and then you find out ways like Patel sir also mentioned, that you start off with a project, you face a challenge, you find a solution to it. It can be either a precast solution, or it can be a conventional solution, or it can be a steel solution. So as a contractor, the idea was that we meet the requirement of the project. So in this case, we have gone with conventional foundations. Parallelly, we did construction at the factory for the columns, beams, and the double T slabs for the mezzanine. And by the time the foundations were done, we had already completed casting of the first level of columns. And then we did the tie beams and the top part of the columns. The PEB structure details were also going on parallelly. So the client had a good experience with the whole process because a lot of details from the process consultants were also pending, which we got incorporated after we got the contract. So a lot of parallel work happens in the project, where we keep on adding the design requirements, the process requirements, the requirements of the HVAC person, the process pipeline person, and so on. There's a racking system that also required a lot of detail changes. And having an in-house design team enabled us to make these changes on the spot faster and incorporating them using precast so that the implementation time is reduced much faster. Otherwise, drawing आएगा, फिर काम करेंगे, कब खत्म होगा, तो थोड़ा challenge हो जाता है. So this is not a time lapse, but just a series of images taken over a timeline. So a lot of in situ work happening during the foundation stages. There was also a challenge because there was a black cotton soil layer of almost 2 meters, which we removed before we started the whole work, which was by the insistence of the client. So by the time the foundations got over, we had a cyclone which dumped a lot of rain and hampered the whole process. Gradually got that working, and then had to work night shifts to get us back on track in the precast portion. The same thing, if we had done conventionally, we could never have caught on those days lost due to the waterlogging in the cyclonic rains. So the column beam connections are cast at site. So the junctions are visible in these photographs. The columns in the center are having 32 anchor bolts of almost 50 mm diameter, which need to be 100% accurate, otherwise the PEB structure doesn't fit. So doing that part at site was pretty much impossible because it's not just vertical. There were some bolts which are coming horizontal as well. So precasting helped us ensure that. As you can see in these pictures, there are a lot of bolts, connection bolts for the PEB. We have done 2-piece columns because the upper part of the column itself weighs around 16 tons. And the bottom part is also weighing almost 12 tons. These are aerial views of the site during the erection process. Unfortunately, the client gave us the process, underground process utility drawings of the building after the precast erection had happened. So we lost a lot of time in getting all those pipelines and everything done afterwards. In hindsight, we could have asked them before. So all these elements that you see, any shape, any form, any kind, with whatever kind of reinforcement, corbels, everything is as per the conditions and requirements of the site, the project, and is done here in Ahmedabad at our factory. There is no rocket science here, there is no technology here, it is just application of the mind and solid engineering. And like everybody told you today, I'll just request you to remember there is no technology here, it is just a methodology difference. You are just using the same IS code, you're using the same engineering that you are learning every day in your college and applying every day in the field. And you are converting into a different method which you are using to deliver your projects better, with more control, with more precision, and at a much fraction of the time you do conventionally. So now that Patel Sahab is also with us, PS Patel Sahab, Harbanak is also here, we are also doing these jobs. I hope you'll appreciate and understand that precasting is the way forward, and I invite you all to join us in this revolution. These buildings are not that hard to do. You are most welcome to visit our projects as well as our factories and help us drive this revolution forward. Can we switch back to the slides, please? I just have one last slide where I'll just show what decisions we took in this particular project and how it turned out. What was the motivation behind that decision and what was the end result of that decision. This was just an example of an industrial project. We have also delivered G+7 structures, G+6 structures, G+11 structures. All are full precast. You're welcome to visit our stall and know more about it. And we are also now starting work. Today actually we started the first pouring of concrete on the precast portion. So for this project particularly, we went with cast in situ foundation and plinth beams because the foundation was too large to transport. Ended up helping us because we did parallel casting of the other elements at the factory. The anchor bolts were too many, so it was good that we decided to go with a precast column. We also saved a lot of money because the steel prices had increased tremendously. So instead of going with the steel column, we used a precast column, helped us a lot. We used a double T slab over a hollow core slab because the client had a strict requirement that we want to puncture holes anywhere we want. So because they did not have all the process lines and everything fixed, we have not used a pre-stressed double T or a pre-stressed hollow core. We used a conventionally the regularly reinforced double T in this case. And in some of the columns we have used M60 instead of M40 grade concrete because the reinforcement was getting too congested, and we modified it to make it happen. So these are some of the salient things we did in this project. I thank you all for being such an accommodative and patient audience. Thanks a lot.
We'll hand over the memento to the team.
Just a moment. Well, Nishant Patel and Samir Patel, the structural engineer, he is an IT person, but he spoke like a structural engineer. Fantastic. He mastered the art of precast, yeah, and does everything. Right? Well, of course, this is the man who is making all the design calculations and all. He's a bit shy in coming to the flight, but he forced him, but he virtually rocked on the dais with his fantastic precast knowledge. Thank you very much. Yeah.